Hello and welcome to another episode of Excel Statistics. Today we will be talking about confidence intervals and hypothesis testing. Our first test we are going to look at is this statement. Assume that a certain hospital wants to claim that its patients spend less than 90 days in rehab. A random sample of 9 patients averaged 77.4 days with a standard deviation of 29.6. Assume the population is normally distributed, test the claim at alpha equal to 0.05. Remember that the alpha value is the opposite of our confidence level, so our confidence level will be 0.95 or 95% confidence. To start our test, we'll always select a null and an alternative hypothesis. Our claim here is that patients spend less than 90 days in rehab. Knowing that we will use the convention of always putting the equals hypothesis in our null statement, this one is a less than, so we will put that as our alternative, less than 90 days. Which means our null hypothesis will be the opposite, which is greater than or equal to 90 days. Next, we'll just make a list of the data that we were given. So we have our mean, which was 77.4. We have our standard deviation, which was 29.6. We have our sample size, which is 9. Just going to widen this out here a little bit. And finally, we have our alpha value, which is 0.05. Next thing we want to do is we want to calculate our confidence. So I will put a label in here. And we will start the formula confidence, and we will select confidence.norm. After I've selected that, I will use my insert function button up here to bring up my function arguments window. And here you can see there are 3 different values that are required. The first one is our alpha value, which we have selected right there. Second, it asks for our standard deviation, which I will grab right there, or 29.6. And our sample size was 9, which I'll grab there. Okay, so this tells us our confidence is 19.3383. From there, we will calculate our upper limit and our lower limit. Now for our upper limit, we're going to say that this is our mean plus our confidence, whereas our lower limit is going to be equal to our mean minus our confidence. So here we've got our range that is a mean plus or minus our confidence, which gives us our confidence interval. So from this information, we can make the statement that we are 95% certain our true population mean is between 58.1 and 96.7. Next, we'll go back and we will look at our null hypothesis and see that it says greater than or equal to 90 days. And then we compare that to our confidence interval. And we see that greater than or equal to 90 days definitely falls within this range. So because greater than or equal to 90 is inside our confidence interval, we accept our null hypothesis. Because that, in more plain English, there is statistical evidence to suggest that the mean days is greater than or equal to 90. And so that's all we have to do for that. Again, the main part here is our confidence formula, which will give us that confidence range. As we change our alpha value from 0.05 to other values, we can get confidence other than 95% if need be. However, a lot of times we're not given just this summary information, and we're actually going to start with a string of data. So I've collected some here over this other sheet where I have commute times. And our hypothesis here was that we believed the average commute time was 20 minutes So here again, we will start with our null and our alternative hypothesis, and we will make those statements from there. So since our equals always ends up as our null, we're going to say that our null is that our mean is equal to 20. Our alternative is that our mean does not equal 20. So for the next step, we need to be able to calculate our mean, our standard deviation, our sample size, and our confidence level. The easiest way for us to do this is like we did earlier with our data analysis toolpack using descriptive statistics. So if we go back to our data ribbon and select our data analysis, we'll grab our descriptive statistics. And for our input range, I'm going to select all the time data that I have. It is grouped by columns. I have my labels in the first row. Select my output range and put it right over here in column F. And then I'm going to ask for my summary statistics and my confidence level for the mean. Now that I have my output, I can begin calculating my upper limit and our lower limit. Since this output gave us our mean and our confidence level, we're all ready to go from here. So we can, for our upper limit, we can grab our mean plus our confidence level. And for our lower limit, we can grab our mean minus our confidence level. So now we see that we have a confidence interval from 21.9 to 47.1. So we can write that here as we are 95% certain our population mean is between 22 and 47. Now, we go up to our null hypothesis and look for our mean equals to 20. We compare that to our confidence interval, and notice that this is not inside our confidence interval. So because equal to 20 is not inside our confidence interval, we will reject the null. I will just scroll up a little here. Because for saying that, we can now state in English that there is statistical evidence to suggest the mean does not equal 20. So that's really all we have there as well. So again, it's really all comes down to being able to calculate this confidence level. Here we use a confidence formula on our first example because we had our summary data and we were able to calculate that. However, if we have our detailed data, we can simply use our descriptive statistics from our data analysis toolpack and get all those summary level data for us and then calculate our upper and lower limits. There we compare our null hypothesis to see if it falls inside or outside of our confidence interval. If it falls inside, we will accept our null hypothesis, and if it falls outside, we will reject the null and accept the alternative. Once again, thank you for watching, and I hope you found this video useful.